Hello students, have you ever shouted in a valley or inside a large empty hall and heard your own voice come back to you? That is an echo. By definition, an echo is the sound heard after reflection from a distant obstacle, such as a wall, cliff, hillside, or forest edge, after the original sound has stopped. Remember, if the reflected sound overlaps with the original sound, it is not an echo. To be called an echo, the reflected sound must be heard distinctly after the first one. So the next time you clap in a corridor and hear it bounce back, you're not just making noise, you're proving physics. Why don't we hear an echo inside small rooms? The reason lies in the minimum distance needed for sound to travel. Our ears can only distinguish two sounds if they are at least 1/10 of a second apart. Since the speed of sound in air is about 340 meters per second, in 1/10 of a second the wave travels 34 meters. But sound must go to the wall and return, so we divide by 2. That gives a minimum distance of 17 meters. In other words, the reflecting wall must be at least 17 meters away for a person to hear a clear echo in air. Now let's see what happens in other media. In sea water, sound moves much faster, about 1,400 meters per second. Applying the same calculation, the distance traveled in 1/10 of a second is 140 meters and dividing by 2 gives 70 meters. This means in sea water, the obstacle has to be at least 70 meters away to produce an echo. So, the faster sound travels in a medium, the further away the reflecting surface needs to be. So, what are the golden rules for hearing an echo clearly? First, the reflecting surface must be at least 17 meters away in air or a larger distance if the sound is traveling in a faster medium like water. Second, the reflecting surface must be larger than the wavelength of sound, otherwise the reflection is too weak. And third, the sound must be loud enough for the reflected wave to be heard by our ears. If these 3 conditions are not met, the echo either won't form or will just blend into the original sound. Here's something interesting. Sometimes instead of a single echo, you hear sound stretched out, almost like it is lingering. This effect is called reverberation. It happens when there are repeated reflections from surfaces like inside domes, halls, or monuments such as the Taj Mahal or Sikandara. The difference is simple. An echo is one clear reflection, while reverberation is multiple reflections overlapping, making speech or music unclear. That's why auditoriums use sound-absorbing materials to reduce reverberation. Let's solve a simple example. Suppose the speed of sound in air is 340 meters per second and persistence of hearing is 1/10 of a second. Using the formula, distance equals speed multiplied by time divided by 2. Substituting the values, distance equals 340 multiplied by 0.1 divided by 2, which gives 17 meters. Therefore, for a person to hear an echo distinctly in air, the obstacle must be at least 17 meters away. Remember, always divide by 2 because sound travels to the obstacle and back. Let's wrap this up. An echo is the reflected sound heard distinctly after the original sound. In air, the minimum distance for echo is about 17 meters, while in sea water it is about 70 meters. To hear an echo clearly, 3 conditions must be satisfied: enough distance, a sufficiently large reflecting surface, and enough intensity of sound. Echo is different from reverberation, which is caused by multiple overlapping reflections. And finally, echoes aren't just curiosities, they power sonar, medical imaging, and even help animals like bats and dolphins navigate. That's the beauty of physics, everyday experiences turning into life-saving applications. See you in the next session with another exciting concept.